Howdy hackers, and welcome to another episode of FairLight TV. Now we're getting into the gory stuff again. This is C64 doing low-level shit. Doing something that nobody asked you to do for no apparent reason, and there are potentially no one interested in the result of your work. That's the life of a C64 hacker. This is a reassembly of a paint program. Yes, over to the disassembly or the reassembly, I would say, of Advanced Art Studio. Damn. Okay, so sometimes I'm doing absolutely ridiculous stuff. I didn't have any sort of game to hack around with, so and there was a discussion on one of the Swedish Facebook groups around the paint program Advanced Art Studio. Yes, Advanced Art Studio, that's the name of it. So for no apparent reason, I took that piece of executable and then I fed it to the reassembler 6502 bench, and I started chewing on the program, see if I can reassemble it to eventually see if I can implement small hacks and all of that. So I will show you a bit of how that is done. So let's see if we can have the spare screen and camera. Okay, so this is 6502 bench. The program is predominantly done for Nintendo disassembly. So there are a number of kind of quirk implementation. I especially dislike this, but I've said that before. It sort of it parses the two first bytes as being something that is part of the binary that will go into memory, but it's not. I mean, the loader takes that, parses it, and then it will never end up in the memory unless you have like a some sort of machine code monitor where you could load it directly and all of that. But yeah, he likes to have it like that, and I've said that because I've been through this program before. So just to give you a little bit of hint on how this work has been done. Can we please? Yeah. No, we cannot. Okay, eventually I will need to do this. There is an issue with Vice. If I keep it on for too long, it becomes irresponsive. And this should be 3.62, some version. Okay, yeah, I will need to make a pause and start Vice again. But so I run through the program and try to find, depack it and have a binary that runs that I can parse, where most of the stuff is on the logical place in memory where it's executed and all of that. So if I want to make a full reassembly of this, that means that I need to identify what's code and I need to identify what's data. And most importantly, I need to identify all the places where there is a reference to something in memory. 6502 bench is really smart. So if you set the start address of something, then it traverses the entire program and where it's executable. And it also looks at stuff that's, if it does like an LDA 0, and then do a branch on equal, you know that branch will always be taken because it previously loaded the LDA 0. And then it doesn't parse the rest of that as code because it's taking it like an implicit jump. But if you want to make it a start of code, there is some sort of way where you can actually execute the instruction after that, self-modifying code or whatever, then you just define the following byte as something you can execute. So it's a new program start. So you set program. unlike other disassemblers I've been using, I've set an area of memory saying parse this as code. This is not what you do here. You set the first of the executed instruction as code, and then it traverses and does all the mapping of what is code and what is not itself. So it's super smart in that way compared to like the regenerator. This is doing a lot more work for you. But I will also show you a few of the other things here that the program can do. And so there is a parallel discussion what the program can do and how I did it in this particular case. Table for calculating. So there is something called Visualiser, which is super nice. In this case, there is like a matrix of sprites that the program uses for a number of different purposes, and it's showing that like here on the very same address. So there is this high-res sprite, and we can have a look at that one. It looks like this. So it's a high-res sprite. You can give it a tag, and this is where it is. You can make it double width and double height. I don't know why you would want to do that. It doesn't really matter if it's sort of expanded or not. But so this is the mouse pointer. It starts there. And a new feature as of 1.8.3, he implemented sprite sheets. So you don't need to manually define each and every one of the sprites. You can, if they are sequentially stored after one another, you can make a sheet out of it. So this is a sheet with the, what would that be, 16 sprites, including a blank one here in the middle. I did that. Well, yeah. Okay, so there you go. These are the sprites that the program use, and that's where they sit. So you make a visualizer, and so the option here would be like that, and then you create and edit a visualization Z. So you get this. So this was the arrow was the first one I did, and then given the new opportunity of this, I could also do this the sheet here. Again, I'm not really sure why you would want to be able to do both, but it's really handy. And there is also one other feature I've requested. So if I have made a visualizer, I might want to suppress the data because I already see graphically what this is. But again, that is on the to-do list of the program. Let's see if he implements that. So joystick, mouse, keyboard, koala pad, disk, and then a blank one. And then there is some sort of garbage data. I'm not really sure what that is. And then the other visualizer here, that's, again, this is also something that's really newly implemented. I can also do a multicolor font here. So there is both a multicolor option and high-res, and the data is parsed differently. But it's also a really handy way of printing what is there. And here, again, I would like to suppress the data because just scrolling through it doesn't make any sort of sense. And then I've identified a number of the locations here that the program used to store data. When it's so this is sort of the general area for settings, and I've tried to rename a number of those that I found to what they have been using when I analyzed the code of what it was using. Yeah, so color paper, color border, color ink. That's something that is available in one of the menus, and it stored the data you set into this location. So there was a text reference to what this was, and then I could see on the code that it's stored to this very location, which means I could rename or name this particular location to that, which makes code a lot easier. And then when I move it around, or if I ever do that, then it gives the assembler would give this address a relevant meaning. So this is all good for now. And you see here that the L here are that's stuff that the program has associated, or it has generated, automatically generated a label for this because there is a reference to this address, but I haven't yet determined what this does. So it still uses sort of the default addressing. And then you have a block of memory. I don't know what that is. It could be garbage. I think this is actually stored. Again, that's more work to be done. I haven't determined that yet. I've dug through the pattern definition, and here I have tried to analyze how a pattern is defined inside the program, and it shows that this is a size in X and Y. So the low nibble and the high nibble tells the size of the pattern, and then you can define the three colors used. So 3 multicolors. Background color is always the same throughout the entire picture, but these are the 3 unique ones for the item or the pattern here. And then you have the actual sort of pattern data, and the maximum size of the pattern is 10 rows high, which means that it's, well, that'll be 80 pixels, and then it could be so 3 bytes wide, so that's that. No, it's not 80 pixel. One of them would be only a pixel row. So this is, it's 16. It's hex 10, it's 16 pixel rows. Okay, and then, so this was the first pattern, and I can only give one label. So this is really pattern 0, because you normally want to 0 index them, but the general reference to the area where patterns are stored is referenced patterns here. Yeah, so that's that. And then there was a high-resolution font. And to be honest, I did take a look into the memory of the running program using C64 debugger, because that is the easiest way to take a visual look into the program. Surely a totally missing feature of Vice, that there is no kind of visualizer of what's going on in the program. So a visual aid for viewing the memory as bright as fonts, as bitmap and all of that would be highly appreciated, but there is not one of those. So let's see, there is a high-res font and it looks like this, so I could identify that, and then I realized that the number of items is also here, so I could trim it down to ensure that I only had the very number of bytes that is visible in the font. Okay, and then again, yeah, that would be good to suppress. And then 1F00, that's actually something that breaks in this version of the program. I'm using 2.3 and the crack is sort of faulty. The best version I found is a rather early version by Kingfisher. Kingfisher have tried, excellent cracker. Still, and also a very nice guy. In launching the program, there is a setup menu where he copies the configuration, and there should be configuration here, because unless there is configuration here, which there isn't in this version, then it's trying to execute code that is supposed to be here, but it's not. So that's part of the configuration, a little bit of the code and vectors to that code. So faulty version. If you look at the version 2.3b in CSDB, I've noted that one as borked because, again, printing doesn't work. So here you would have the bitmap, the main bitmap, and there are pointers into the bitmap, and this, of course, couldn't be relocated. This has to be on address 2000, but there are pointers to the start of each of the rows. Yeah, this one looks strange. It's not supposed to be here. There should only be that, because they should all be 320. And then there is something here. I think that's just empty. Yes, and here, yeah, not sure what that is, but let's not dive into all of the details here. But so the start is 4729. In all the versions I've seen, that's sort of the start address. And then I just follow the logic of the code and try to see what it does where, and try to make notes. This is how I normally approach a crack as well. I run it through into the disassembler, and that's where I document my findings of what the program is doing in the relevant part of where it's doing whatever it's doing. Because, yeah, back in the days I could just run around using my machine code monitor, and I tended to remember all the notes I've done. But now, or I had the entire desk full of scribbly notes. But now I'm more kind of structured, but more forgetful, I guess. So I'm pasting all my findings into the debugger or the reassembler, such as I've done here. And then so in this particular program, I realized that whenever you select something inside the program, that's address 5040. And when it reaches address 5040, it's pointing towards a structure. So all the menus are structured. Structures, I should say, such as this one. So you see here a number of bytes, and so the process that is still ongoing is trying to understand how that structure works. But what I have so far is that there is sort of this one should be like that. That is a word. I haven't gone back to this yet. Yeah, so it's the X and the Y of where the menu starts, and then there is the width and the height of that, and then there are two parameter bytes, and I haven't fully understood those yet. So that's where I'm at when I run this. And then there is a vector, and then no, that should actually be byte. So then there is a vector, and then so that's the header of the sort of menu structure here. But if we look at one of the items, it would be this. So X, Y, width, height, those two magical parameter bytes, and then a vector of where the program will, what the program will launch, and also the text that the menu item has. So this is how it's building the clickable interface using structures such as these. And so this is likely, yeah, so when I try to denote it, it's the menu here. So the menu means that it points to another structure, and then I've tried to do as a prefix for when it's something that it's executable. So I think those magical parameter bytes somehow marks if it's an executable vector, or if it's pointing towards another menu structure. I don't know if we can scroll through it. Font numbers. Yes, so this is a little font that is, oh, I can do that. I can do a visualizer here. Let's do, and I only place myself on the first one here. So we'll do a visualizer and a new visualizer, and this is a font, a high-res font, and the number of items would be 10, right? There we go. Now we have a visualizer that shows the content of this. I don't know if the zeros should also be part of this. So let's do 11 then. See if that makes more sense. Yes, now it's also including the last space. I mean, you can't tell, but if Andy McFadden, the coder of the program, implements that having a visualizer would also mean suppressing the subsequent data. I need to have that perfect fit of the visualizer. Otherwise, I would be hiding something that's actually code, and I don't want to do that. Pointers to the bitmap, we went through that. That's what you saw above. So these points to the first pixel of each of the bitmap lines. And then you have something here. So this is the low byte, and then you have a section which is the high byte here. And that should be here. And to be honest, I think this means that so it's working on all the 25 rows, and I think it has sort of pointers to a little area which is sort of the, I don't know, work area. So you can write something which is outside of the visible screen. I'm not really sure, but there is a definition of 28 lines here, and there is a definition of 28 lines here as well. And the same is applicable for the screen memory here. I haven't made that table structure here. There is a bit of an issue when you make a table structure which is outside of the area you have defined your code in. So if I define something here, this is screen high and screen low. So this is 0400, and then the next one is 0428. And if you know where your screen memory is, that makes total sense, because the first byte of the second row is 0428. So that's what it is. But yeah, I can't really do that for... I think there is an issue if I do this format address table, and then no, why isn't it doing like that? Format address table. So the low byte would be this. Makes sense. Yes, split the code. Oh, here we go. So what I did now was that, so the normal definition would be low byte, high byte, low byte, high byte, like interleaving, having the full word in low byte, high byte order, but so every second byte is low and every second byte is high. But if it's split, so you have a number of low bytes and a number of high bytes, then you make that, you tick the box to your part, so split across subtables. And also, if this is a table that is jump table, a number of addresses where you pick the address and then you execute it, you tag this, so you make all of them a starting point. That helps the debugger to find the starting points without specifically defining all of them as starting points. Very handy. But no, it didn't work. So yeah, again, that's a restriction of the program. Here I did all the configuration I should, as far as I understand, but it wouldn't do the 0400 here because it's external. The same is valid here, and this is also something which was sort of the first thing I did. So this is the column memory. It's the same structure as the screen memory here. It's only pointing at D800 and D828 and D850 and so on. Again, it's outside of the scope of the program, so it will not allow me to do this. What else can I do? So if I've selected the option, the menu option undo, this is what it's doing. And one of the things I really need to do is ensuring that I capture all the LDA, low byte, LDY, high byte, and then jump to something. That's a very common way to denote low byte and high byte as absolute. And I need to find all of those. Otherwise, it will not be able to sort of relocate properly. So if I insert a byte so that the address for any given sort of function changes, unless I've made all the changes such as that one, then it will not work. Then it will still point to the original point. I need to change all the absolute addressing into something that points to a vector or a label, and that label could then change when I assemble it again. Okay, I'm not really sure there are that many things I would like to do more. Yeah, tables, and again, I'm well into this, and I've done a lot of the commenting, and all the menu options I think are sort of in place now, but I haven't followed all the logical paths that the program can take. But looking how you do here, so what you do now is assemble. So now it takes the configuration file that I've generated and it makes that into a turbo assembler source file, and then I run the assembler. And it's not because I want that file, but the only thing I want it for is to ensure that the output matches. So output matches data file. That means that the reassembly as it is today generate, if I generate the source and I assemble that, the binary that will export is going to be 100% as the original. But that doesn't mean that if I start relocating, if I start changing anything in the code, that I have ensured that I've sort of captured all the parts that are absolutely dependent and made them depending on a movable label. Yeah, what else can I show you here? I don't think it's that much. Let's see here if we can. I'll just go and start Vice. Okay, so an instance of Vice, and I have placed the program there. You can do load from here. So here we go. That's where the program is. So, and then I do this break. Again, that was the address I identified as sort of, I've now selected something. And then I would need to ensure that all the calls that the program is doing based on clicking something in the user interface is something I also ensure is defined as code. So that was the break there. And then command 1, M3B3C, and then M3031. So what this one is doing is whenever the program hits that breakpoint, it will issue the command M3B3C and then also M3031. It will show 4 addresses in memory, basically it's showing 2 vectors. And the reason for doing this is that basically every time that breakpoint is triggered, that is something I would like to do because I would like to see the content of those 2 addresses, or those 2 words basically. So it's rather convenient to have Vice monitor do it for me, so I don't really have to type that every time. Okay, so here now I don't really need that. So let's do fill, solid fill, and here we go. So what this is, this one is the jump. So the fill is, and let's do G7133. And here I've done do solid fill. So this is already something I have found, and I have documented that this is what it's doing, and this is what it's doing there. And then 483B, it's not really true because this is not updated at the time when I'm here, but that is the main menu. 483B, 483B. So this is the main menu. So you have actually selected the menu fill. So the fill menu was here. Yes. Oh, we can do something else. Magnify. Okay. A6OA. Do magnify. So I've already identified that that is something where that goes. One of the cool things about the program, I should tell you this as well, because if you want to use this for your own purposes, there are a number of really smart navigation things which aren't really apparent unless you read the manual or ask poor Andy to help you with that. So sim data here. If I just click that, it will go to the place that reference where I was. I'll go back and do that again. So here is the address, A6OA. Here you would have the addresses that references that. So we don't need to do this one, 51, that's a branch. It jumps to itself, so we don't need to care about that. But where I've defined this, the magnify menu structure here. And so what this does here is that the menu structure, first it picks a number of parameters, you know, the X and Y. And as we remember, I think the menu was blue, and here is blue as the color. And then there is some menus pick values from memories and populate them. And magnify is one of those, because you can set the magnification level between like normal X2, X4, and X8. And so the init of the menu before it actually prints is also picking up that value, so it could set the check mark on the appropriate magnification level that the program used. Let's see here, and A5B6 was so here you see that A5B6 is this menu, and A6OA is the vector it picked up from reading that menu. So here it's correct when I'm like one step deeper into the structure of the program. Both of the values are correct. And here you have the magnification 2x, 3x, 4x, and 8x, and then you can have a magnification grid. So when the magnification is on, you can have a grid that shows the pixels. So if I select that, 48.3b, it's still the same. Oh no, sorry, that's now it's going back to because now it wants to show the main menu. So it set the pointer to the current menu structure to where it's going, which will be the main menu. So the blue and white one you have on the top. But A654. Here we have do magnify. So it called that using the menu option you selected. So it has a lot of tricks for reusing the same piece of code for multi-purposes, and the magnifier is for sure one of those. And you see here that the magnifier size here is the I've captured that as well. So that is the parameter it stores if you select it. All right, print data. That's this is for sure something that I haven't done. It looks like code. Here is a set interrupt. A9. Possibly not. Yeah. So well, yeah. That's a structure, and I haven't looked into that yet. So again, disassembly of tools could be very cumbersome, so I'm not really sure I will ever do this. But if you are interested in getting access to the source, or the project as such, and would like to contribute, this is actually something I've also synchronized with GitLab, so I can do this. That's the other thing I do. Let's save that and exit that. I should also possibly show you this. I'm also sort of always keeping sort of a log. I use a normal text editor, and I tend to use Sublime because that's also my coding editor and I paid for it, so why not use it for this as well? So I've documented the structure, what they are doing and all of that, and there is also all the options in all the menus to ensure that I've sort of captured all of them, so I do that as well here. So that one I also store, and now I can stage that, and I'm sure that a number of you who are coding and using some sort of shell tool to do your Git work. I'm sorry, I don't do that. I do this. So for the fans of FairLight TV, I commit that and I push it. Right, so now I'm pushing, everything is up to date. So now the project on GitLab is updated with the content I have so far. So that was everything I planned to say for today. I've been doing a lot of reassembly, and to be honest, this is sort of the first project where I wholeheartedly dived into doing this on based on 6502 bench, and I used to do much of this in Regenerator. And yeah, Tomas, I'm sorry I've surrendered your program. It was great. It was sort of I knew what I had, but eventually I needed to move on. So this is where I am now, and that's how I would approach a reassembly of a tool on the C64. See you next week. Bye bye.